Okay, so what we're going to look at now are what are known as acids and bases. Now, in order to really understand acids and bases, we need to kind of take a look at a couple of things. So the first thing we want to look at is we want to look at water. Now, if we think of water, so water, we can call it, it's H2O. So what that means is that you have an oxygen atom and it's bonded to two hydrogen atoms, like so. Now, what happens is the oxygen and the hydrogen atoms, they share electrons with each other. These are what are known as covalent bonds. And just a little recap on this as well. So let's have a look at, so if we take here, so we have the periodic table. So if we look at hydrogen, so we'll take out hydrogen. So remember, hydrogen is a group 1 element. It's within the first group on the periodic table. And then if we look at oxygen, so oxygen, as we can see here, it's a group 6 element. And we'll just take the two of these and we'll bring them up and we'll have a look. So let's have a look at these. So let's take, so if you remember, we talked about how we can represent the structure of atoms, and we can use what's called the Bohr structure. So let's just, as a little bit of recap, we look at the Bohr structure for hydrogen. So remember, hydrogen, an atom of hydrogen, in the middle it has what's known as the nucleus. So we can represent this with a circle like so. So this is the nucleus. And then inside the nucleus then you have two types of what are called subatomic particles. So remember, you have, and we'll just write them over here. So subatomic particles. So one of the particles that you have are what are known as protons, and we can represent them with a P. So protons. And remember, protons, so some of the characteristics, they carry a positive charge. So we'll just represent that with a plus. So they carry a positive charge and they have a mass of what's known as 1. So these are protons and they are contained within the nucleus of the atom. So remember, this circle that we're drawing here is the nucleus of the atom. Now, how do we know? Let's say we look, so we're looking at oxygen at the moment. Or, okay, we will look, so we look at oxygen first and then we look at hydrogen. So oxygen, to find out the number of protons that oxygen has, we look at this number here, which is known as the atomic number. And that tells us that oxygen in the nucleus, it has eight protons. Another way to think about it as well is that it has 8 positive charges inside the nucleus of the atom. Now, also within the nucleus of the atom, okay, so that's the protons, you have what are called neutrons. So neutrons are, there's no charge, so we just draw a circle with nothing in it, and they also have a mass of 1. Okay, so there's a mass of 1. Now, if we want to figure out the number of neutrons that are present within the nucleus of the atom, so we take this number here, okay, which is the bigger number, and this is known as the mass number. And the mass number is made up of the number of protons and the number of neutrons. So what we can do is we can take the mass here, which isn't a whole number, and we can make it a whole number. So we'll just say it's 16. So what we can say from this is that if the mass is made, so remember the mass is protons and neutrons. That's where it comes from. And protons have a mass. So remember, protons have a mass of 1 and neutrons have a mass of 1. So what we can say is that if the mass is 16, then that mass, where's that mass coming from? So you're getting 8 of the mass units are coming from the number of protons which are in the nucleus, and then if we take 8 from 16 we get 8. So therefore the other 8 has to be coming. So if 8 of the mass is coming from protons, then the other 8 has to come from neutrons. So we have 8 and 8. So what we can say then is that the number of neutrons then that are present, the number of neutrons is also 8. So both of these subatomic particles, so these are what are known as subatomic particles, and they both, as we remember, their location, they both hang out in the nucleus of the atom. So that's where they hang out. So this is the nucleus of the atom. Now we know as well that there's also another subatomic particle, and we call these electrons. So we call them electrons. They have a negative charge. So remember, they carry a negative charge, so they're opposite to the protons. They're negative charge, and they have a very, very small mass. So you can nearly say that the mass is like it's nearly non-existent, but if you want to look at it as a fraction, it's roughly 1. Let me just get this here. So it's roughly 1 over 1840. So it's about 1 over 1840 of a mass of a proton or a neutron. So it's a tiny fraction in relation to the mass of a proton or a neutron. So again, it's almost negligible. So how do we know the number of electrons that are present? So the atomic number, that tells us also if there's 8 protons, then there is also 8 electrons. Now, atoms, their overall charge are neutral. So what that means is that if we have, so imagine we have 8 protons. So you have, let's say, 8 protons. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 protons within the nucleus. Then in order to counteract that, so let's say these are 8 positive charges. And in order for the atom to be neutral, so imagine these are 8 positive charges, so they're all positive. You have to have 8 negative charges, and those 8 negative charges come from the 8 electrons. 2, 3, 4, 5, 7, 8. So 1, 2, 3, 4, 5, 6, 7, and 8, and these will be negatively charged. So what's going to happen there is that the 8 positive charges will neutralize the 8 negative charge. The 8 positive charges will neutralize the 8 negative charges, and the overall charge on the atom is going to be neutral. Now, if we think about the electrons, so where are the electrons located? So the electrons are located in what are called orbitals. So for example, with oxygen, so you have this first orbital, and orbitals are really just regions in space around the nucleus of the atom. So you have this orbital, so that's the first one, and then you have the second one. Now if we remember, the first orbital can hold up to 2 electrons, so 2 electrons can move around within this space. So we can just represent those. So imagine this is these are the first two. So remember, oxygen has 8 electrons. If it has 8 protons, it has to have 8 electrons. So 2 of those electrons are in the first shell, and the first shell, it's full when it has 2 electrons. The first shell, the shell nearest the nucleus, can only hold 2 electrons. So what will happen is these electrons will just move around within this space that's close to the nucleus. Then the second shell can hold up to 8 electrons. But because we've taken 2 electrons, so we have 6 remaining. So those 6 electrons are contained outside in the second shell. So we've 1, 2, 3, 4, and let's say so 5 and 6. So you have 2 electrons in the first shell, and then you have 6 electrons in the second shell. So this is our oxygen atom. So again, you have the nucleus, you have 8 protons, 8 neutrons, and then outside in the orbitals, you have, or the shells, you have the 6 electrons. So the location of this, okay, so is in the shells or orbitals. So that's basically just these regions in space out here where the electrons can move around. So that's oxygen. Now if we think about hydrogen, if we do exactly the same with hydrogen, so again, we can draw our nucleus. So imagine we have oxygen. Okay, let's make this a little bit bigger. So this is your nucleus. Inside the nucleus, so you have the atomic number, which is 1. So you have protons and you have neutrons. So how many protons have we got? We've got 1, and we've got 1 neutron. So that's the, let's say, where the 2 subatomic particles, protons and neutrons, are contained. What we have then as well, so we have the shells. Now if we look at if we think about hydrogen, hydrogen just has 1 shell because it only has 1 electron, and that electron is going to hang out here in this 1 shell. So remember, the first shell outside the nucleus, it can hold 2 electrons, and hydrogen just has 1 electron in that shell. So that's so this is, if you like, this is the Bohr structure for hydrogen. Now, if we think about, so when we looked here, if we think about a water molecule, or H2O, so basically a water molecule is made up of 1 oxygen atom combined to 2 hydrogen atoms. So why does that happen? Okay, if we think about, so what does hydrogen want? So hydrogen wants 1 more electron in its outer shell. If we think about oxygen, what does oxygen want? Oxygen has 6 electrons in the outer shell. It needs 2 more in order for it to have 8 electrons in its outer shell and that outer shell to be full. So it wants 2 electrons. Now, what can happen, or what happens, is hydrogen and oxygen, they combine and they share electrons with each other. So imagine we have, so this is kind of like what it would be like. So imagine we have our oxygen molecule, and we'll just move this down here a little bit. Okay, so this is our oxygen, and we have a hydrogen here. So what's going to happen, and I'll just maybe make this a different color. So imagine this is your, so I'm just changing the color of the electron for hydrogen. So what's going to happen is oxygen and hydrogen, they can share electrons with each other and have a full outer shell. So imagine what's going to happen is So these are going to come, this is going to come into contact with here. And this electron will come in here and share with the hydrogen. And then imagine we just take the nucleus here. So what's going to happen is, so the orbitals are going to overlap, and you're going to get the hydrogens will share the electron, like so. So imagine then what's happening is these shells are overlapping, and then within here, so imagine then I'll just take this little piece out here, make it smaller. So I'll make this smaller, so it's just the nucleus. So the nucleus is here, and then the same thing is going to happen. So you're going to get two hydrogen atoms. So you need two of these. So imagine this one comes from this side here. So imagine we put the okay, so imagine then this other atom of hydrogen, it comes here, and what's going to happen is it's going to share its electron. So it's going to share its electron here. The orbitals are going to overlap, like so. And then what's going to happen is you'll get this nucleus. Imagine this nucleus would be inside here like that. So what's essentially happening is you are getting, so this here then, so where we have this overlap, so let's say, so where we have, so here and here, what you have is you get what are known as covalent bonds. Here, covalent bonds. So they're covalent bonds. So basically what happens now is we have oxygen. It has 6 electrons in its outer, or 8 electrons now in its outer shell. 2 of those it shares with hydrogen, and then hydrogen gets to share some of the electrons with oxygen. So it gets 2 electrons in its outer shell, and as a result of that, both atoms have full outer shells, and they're much more stable like that. So if you think about, so if we have a look up here, so that's the structure, let's say, of the water molecule, and we can think of it like we could as easily draw it like this as well. So each of those lines, this is what's going on here. You have the sharing of electrons, and it's what's known as a covalent bond. Now, what can happen is water can split, so it can, and you can get, so if you take, so you can get an oxygen, an OH minus and a H plus. So these are what are known as ions. Maybe I might make those different. Color some good the background. So let's use this here. So what can happen is this, like H. So if you take oxygen or H2O water, what can happen is this bond here can split, and as a result of that, you will have OH, you have OH ions, which this is negatively charged, and then you have H plus. You have two types of ions. So you have hydrogen ion. You have a hydrogen ion, and then you have what's known as a hydroxide ion. So if you're to look at this, so this ion here, this negatively charged ion, is what's known as a hydroxide ion. Hydroxide ion. So that the hydro part comes from the hydrogen, and the oxide part comes from the oxygen. So you have a hydrogen and an oxygen. And this is a negatively charged ion. Okay, so it's called a hydroxide ion. And then on the other side, then you have this guy here, which is known as a hydrogen ion. So ion means, so we should put this up here. So this is a hydroxide ion. So ion means it's a charged particle essentially. So you have what's known as a hydroxide ion, and then you have a hydrogen ion. So if you were to think about like what this is, so the hydroxide ion is essentially it's one half of this water molecule, and then a hydrogen ion is essentially all it is just one proton in the middle. So it's called a hydrogen ion. It's also called a proton, because if you think about what this is, it's basically just a hydrogen ion like this here. It's just like this, except what's happened is it has lost this outer electron. So this outer electron here, it's actually lost it. Okay, so it doesn't have that anymore. So what's going to happen is it's just going to have, in the nucleus, it's going to have one proton. Protons are positively charged, and as a result of this, it'll be positively charged. If we think about what this is, okay, so essentially what this is, if we were to take so this is essentially what this is, and I'll just clean it up a little bit. Let's just zoom in here. And we'll just tidy this up a little bit. So just bear with me now, 1 second. I just want to get rid of these remnants of the shell. So if you think about this, so if we think about this species here, okay, the hydroxide ion, so it's negatively charged. So why is it negatively charged? Okay, well, if we think about the arrangement, so with it, you're going to have 8 protons, okay, which carry a positive charge. So imagine you have, so 1, 2, 3, 4, 6, 7, and we'll just go up here. So 8. So these positive charges are coming from the protons that are in the nucleus. But how many negative charges then do you have electrons that are moving around, let's say outside between the hydrogen and okay, and between the hydrogen nucleus and the oxygen nucleus. Now, actually, if you think about it, we actually have, so you have 8 protons from the oxygen nucleus, but then you also have 1 proton from the hydrogen nucleus that's attached onto it. So you have 9 positive charges. And then if you think about it, how many negative charges do you have? You're going to have 10. Okay, so you're going to have 8. So 1, 2, 3, 4. You're going to have 8 negative charges. So what you actually do is you've 10 negative charges. Okay, so you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you're going to have 1 more 10. So therefore, the overall charge on this entire species is going to be negative. Now, if we think about it, where are the 10 negative charges coming from? Well, what happens is when this splits up, it takes one of the electrons. So it has this electron from the hydrogen that it stays bonded to, but it also splits up with the hydrogen atom, but it also keeps its electron. So it has an extra electron here. So what's going to happen is there's going to be an imbalance of positive charges that are coming from the nucleuses of both of these atoms that are joined together, and the negative charges coming from the electrons that are orbiting around in the orbitals between these two groups. So you continue to have the covalent bond here. So what happens is this overall, let's say this combination of two atoms, the hydrogen and the oxygen, forms a hydroxide ion, and it is it's negatively charged. Whereas if we take the hydrogen, okay, the hydroxide ion, it has if you like, it has one positive charge in its nucleus, and it doesn't have any electron to counterbalance that. So as a result, the overall charge on this is going to be positive. Okay, so it's positively charged. Now, what's really important in relation to these, so when you take you have the hydroxide ion, which is, let me just try that again. So you have the hydroxide ion, which is negatively charged, and the hydrogen, or the proton, that's positively charged. This is what determines what an acid or a base is. So if we take an acid, and then we take a base, we have our acid. So imagine we have a solution. So you have a container that contains a substance, and then you have one here. You have another solution that contains a substance as well. Acids will have more of these H+ ions inside it. So the more H+ ions that are present, the more acidic the solution is. The more, and therefore it is an acid. So the more of these hydrogen ions that are present inside a solution, the more acidic it is. If we take a base, then, for example, a base is going to have more of these guys within it. So imagine this is your base, you're going to have OH, loads and loads of these OH ions. OH ions that are present. And this will be known as a base. So this is what a base is. So if you want to distinguish an acid from a base, an acid has lots and lots of, the amount of these hydrogen ions that are present inside of it will be huge. They'll have loads of these. Okay. Whereas if you take a base, and you're to look at the amount of these the ions that are present, it's actually they have a load of these hydroxide ions present. They'll have more hydroxide ions present. So depending on where you go, so let's say for example, so we can do it like this. So OH ions and H plus ions. So if we have, let's say there's more H plus ions, it's acidic. The solution is acidic. If it's the opposite way around, there's more hydroxide ions than hydrogen ions, it's basic, or it's a base. And if we have, let's say, the number of hydrogen ions is equal to the number of hydroxide ions, then it's neutral. And that's really what we mean, like when we're distinguishing acids from bases, that's what we're talking about. That's what we mean. So an acid just has a lot of these H plus ions, and the base has a lot of these OH ions. Now, if we were to think about just two very common examples of acids and bases, so if we have a look here, so we have hydrochloric acid, or HCl, which is this one. Okay, so that's HCl, and then this one here, which is known as sodium hydroxide, NaOH. So this is so for example, this here HCl, the one on the left is an acid, and the one on the right, NaOH, is a base. So what's going to happen is, if you take HCl, for example, HCl, okay, sorry now, or hydrochloric acid, and hydrochloric acid is the acid that's actually in your stomach, that your stomach uses to digest food. So imagine you have HCl, and when you put that into water, for example, it's going to split up into H plus ions and chlorine ions, okay? So it's going to create loads of these here, H plus ions. And if we remember, an acid produces lots and lots of H plus ions. So this HCl is an example of an acid. Hydrofluoric acid is what it's called. So when you put it into solution, it increases the amount of these H plus ions that are generated, and therefore it's what's known as an acid. If you take this base here, so we have the base, which is sodium hydroxide. So this is sodium hydroxide, it's NaOH, it's a base. When you put this into solution, what's going to happen is it'll become an Na plus ion, and then it'll produce loads of these OH minus ions, or hydroxide ions. So if we remember, if we take the hydroxide ions, we get, if there's a lot of NaOH in solution, you're also getting an awful lot of these OH minus ions, which is what a base is, okay? So if you were to look inside here, you were to look inside this bottle, inside the HCl, you're going to see loads and loads and loads of these guys here. If you look inside the sodium hydroxide, the NaOH, you're going to see loads and loads of these hydroxide ions present. So as a result of that, the one on the right, sodium hydroxide, NaOH, is a base because it produces loads of these OH minus ions. Hydrochloric acid, the one on the left, is an acid because when it's in solution, or if you're to look inside this, it's going to contain loads and loads and loads of these H plus ions. And that's how you distinguish an acid from a base. Now, just one other thing I just want to touch on before we finish up. What you'll notice is, let's say we took the labels off and you didn't have any labels on either of these bottles here, you can see that both of them are colorless liquids. So it would be very hard for you to look at both of these and say which one is the acid and which one is the base. So what we do is, or what we use this stuff that's called litmus paper. So imagine, so let's say this is, okay, so you can have blue and red litmus paper. So imagine this is blue litmus paper. Just fill it up. So we have blue litmus paper, and then we also have what's known as red litmus paper. So imagine this is our red litmus paper. So these are what are known as litmus paper. Let me just get a pen. So it's L-I-T-M-U-S, litmus paper. Now, if you take this blue litmus paper here, and if you were to put that into the acid, so imagine you take this blue litmus paper and you put it over here into this acid, what's going to happen is it's going to change color. So it's going to go from blue. So imagine you just dip it in. So it's going to change color and it's going to go from blue to red. So it's going to change color from blue to red. So it turns, so an acid also, it will, one of its properties is it'll change blue litmus paper to red lip. It'll change its color to red. And then if you were to take, for example, the opposite then with a base, so that's an acid. So we'll just write this beside it. So an acid, it will turn blue litmus paper red. And the opposite then, so imagine if you were to take this red litmus paper and you were to put it into the base, the sodium hydroxide, what's going to happen is it'll change red litmus paper to blue. So it'll change color, it'll change it to blue. Okay, and that's what's known as that's the base. And that's just one way that you can distinguish one from another. So this is just, it's just a, again, we're going to go over a lot of this, and we'll go over it a few times as well until you completely understand it. But that's, so as an introduction to acids and bases, that's what acids and bases are. So just as a reminder, so the main thing that, like, what distinguishes an acid from a base, it's these ions. Okay, so you have the hydrogen ion, which is this H plus, and then when you have lots of these inside of your solution, the solution is considered acid or an acid, and it's what's known as the hydrogen ion. The opposite then of that is what's known as the hydroxide ion, which is this one here, OH minus. It's negatively charged. So if you have lots and lots and lots of these hydroxide ions within a solution, the solution is considered basic. So a way to identify it is you can use litmus paper. So an acid will turn blue litmus paper red, and a base will turn red litmus paper blue. And just a very, very common example, there's loads and loads of different acids, and we'll talk about them in a little bit more detail, but these are two very common examples of an acid and a base. So what you have here, you have on the left hand side, you have HCl, which is known as hydrofluoric acid. It's the acid that's in your stomach, that your stomach uses to digest its food. And we have a base, then an example of a base is sodium hydroxide, or NaOH, and this is known as a base. When you put hydrochloric acid into solution, it generates loads and loads and loads of these positively charged ions, which makes it acidic. When you put a base into solution, it generates loads and loads and loads of these OH minus ions, which makes the solution basic. So that's what we mean. So that's what we mean by just a quick introduction to acids and bases. Okay, thank you for your attention.